Hey guys, here we are with question number 5 from the exam 3 test review, talking about populations and then taking samples from that population, sampling distributions. So here, my entire population is a population of 3 numbers. I've got the number 1, 5, and 8 in my entire population. So then what I'm going to do to simplify this sampling distribution is I'm going to look at samples from the population of size 2. So that's what's going on with this little table here. I'm going to take every single population of size 2. And I'm going to go ahead and fill in the ones that are missing. I've got 1, 1, 1, 5. The last one that's leading with a digit of 1 would be 1, comma 8. Then continuing on, it looks like I've got 5, 1, 5, 5. The next one would be 5, 8. And then continuing on, 8, 1, 8, 5, 8, 8. So that's all populations. That's all samples from my population of 2. If you look at my population of 1, 5, and 8, the only ways that I can grab 2 elements from that population are the ones listed in that first column. The second column lists the probability of each of those occurring, and because we are in a simple random sample, the chances of each of these occurring are the exact same. So 1 out of 9 for each one of these. I'll go ahead and fill that in. The reason those are all equivalent to 1 over 9 because we are in a simple random sample, and the chances of each of those sample groups of being picked is the exact same. All right, now the real math comes involved here is to determine the values of p hat or x bar. Remember, p hat and x bar are both values referring to samples. So in this case, my p hat, I'm going to do this in green, is talking about the proportion of odd numbers. So I got to look at my sample and see in my sample what are the proportion of odd numbers in that sample. In this case, I've got 1 and 1. Both of those are odd, so it's 2 out of 2 or 1.0. That's my proportion of my sample that's equal to odd numbers or have odd numbers in my sample. Continuing on, next sample I have 5, 5, the one that's missing. I've got 2 out of 2 or 1 whole. So the proportion of my sample that's got odd numbers is 1 whole. If you look at, let's look at this very last one down here that I've got to fill in, 8, 5. Well, one of those elements is odd out of the 2 total elements, so that is equal to 0.5. So the proportion of each of those samples that are odd is listed in that row right there, that column right there with p hat. So the key thing here to think about this type of problem, what we're really doing, is this entire column is estimating the true population proportion, the proportion of the population that is odd. You can quickly, at a moment's notice, see that the population, the true population proportion that are odd elements is equal to 2 out of 3, because 2 of the elements from the population are odd out of the 3 total. But this column that I've highlighted here in green is taking all the samples from that population and calculating the proportion of odd numbers in each sample. The key thing to talk about with this entire section in the book is this column of samples. This does not give me the exact population parameter, but it gives me a good estimate of that population parameter. And if you average all of these, something special happens. And we'll do that in number 6 in just a second. So let's go ahead and finish up my x bar. In this case, my x bar is going to be the sample mean of each sample. So that's just the average of my 2 elements. So I'm going to come back in here and let's see. I've got 1 and 5. 1 and 5 together is 6. So 6 divided by 2 is 3. Then I've got 5 and 8. 5 and 8 together is 13. 13 divided by 2 is 6.5. And then I've got 8 and 1. Averaging that is going to be 4.5. So I've got all of my sample means and my sample proportions developed here. The next question is to be able to calculate the mean of the sample proportion and the mean of the sample means from the table above. So let me reiterate what I did with the proportions. All of these numbers right here in this last column, those are sample means. It's taking the average of the elements in your sample. So I've taken all these samples of 2 for my population. Then I've done some calculations on them. I did the proportion of each sample and the mean of each sample. And then I got all of these values. And these values that are highlighted here in yellow or green don't tell me the true population mean or the true population proportion of odd numbers, but they give me a nice little estimate. Now I'm going to go ahead and cheat, and I'm going to think up my entire population. And I know that the mean of my entire population is going to be 8 plus 5 plus 1 divided by 3, and that's going to be 4.5. 0.6 repeating. So that's my true population. And again, the numbers highlighted in yellow and green don't tell me the true population or the true proportion. But what's nice about them is if I average them, I'm going to get the exact values. And that's really, really nice because in the real world, you're not going to be able to get a true proportion for your entire population or a true mean for your population. But you may be able to gather several samples like we've done here. And if you gather most of the samples in your population or a lot of the samples in your population, then you're going to get some estimators that value very, very close to the true parameters. So you should be able to explain that process just like I did over this little video clip for the test. But let's go ahead and solve the questions below. So the bottom two questions are asking you to find the mean of the sample proportions and the mean of the sample means. So if I average up that green column, again, I'm going to get 7/9. Now, you should be seeing and saying 7/9 does not equal 2/3, so something is wrong. And the mistake actually shows up right here. This very last value should not be 1.0, it should be 0. I don't know how that typographical error occurred, but that should be 0. And then when you average those columns up, you end up getting 6/9, which is exactly what we want because 6/9 does equal 2/3, and that's the average of the sample proportions, and that is the true proportion. So that's really, really nice. That is equal to P, and that's equal to the average of P hats. So that's very, very interesting. The last one's even easier, and it does give you the correct value. We're just trying to find the average of X bars, my average of my sample means, and that ends up being 4.6 repeating. I'm not going to show you how I did the average right here on this video because I know all of you guys can use a calculator to do that.